Hi, scientists. As the days are growing shorter and it's getting darker longer, I thought it might be fun to do an experiment with some glow sticks. And I have a helper here who is going to break my glow sticks open. And if you're wondering why cracking or bending glow sticks makes them start to glow, it's because each stick contains two different liquids. There's an inner glass vial that contains hydrogen peroxide, and then surrounding that vial is something called phenyl oxalate that has a dye molecule in it. And depending on what color your glow stick is, that dye molecule is going to be a little bit different. But when you bend it, you crack the glass vial and it breaks and releases the hydrogen peroxide, and so it can interact with the phenyl oxalate. And hydrogen peroxide has a lot of it has oxygens that are reactive on it, and those have electrons that can transfer energy to other molecules. And so when it transfers the energy to these dye molecules, they release that energy as light called photons. And what we're going to test right now is we're going to see if temperature will change how bright our glow sticks glow. And so we put a glow stick in room temperature, a glass at room temperature in the middle. On the right hand side is hot liquid and hot water, and on the left hand side is ice water. And what you can see is that the ice water is glowing much more dimly and the hot water is glowing more brightly. And that's because molecules, regardless of what molecule it is, will always move faster at warmer temperatures and slower at colder temperatures. So that reaction between the hydrogen peroxide and the phenyl oxalate dyes are happening much faster and more quickly in a warm temperature, which makes the energy get released more abruptly and more at once, so it looks brighter. Whereas the molecules are moving more slowly at cold temperatures, and so the energy is getting released, the reaction's happening more slowly, and the energy is getting more released more slowly, and so it doesn't look quite as bright. But it will last longer at cold temperatures because it is happening more slowly. Anyway, this is a really easy and fun experiment that you can try at home. I hope you get to try it, and until next time, keep discovering.